Welcome to Homework Lib.
Hi, so over here we're going to have the following questions. In this case, the reaction is not provided, but by the context, we know that it is going to be the reaction of water with oxygen in order to produce hydrogen peroxide. So the overall reaction that we're going to have is going to be 2 of water plus oxygen, which is going to produce 2 of hydrogen peroxide. Now, a lab is going to have 32 grams of water and 0.35 moles of oxygen available. What is going to be the limiting reagent of the reaction? So first of all, 32 grams of water is going to be equivalent to, remember that the molecular weight for water is going to be 18 grams per each mole. 32 divided by 18 is going to give us 1.77 mole of water. This amount of mole of water can react with 1/2 of this amount. How do we know that it can react with 1/2 of this amount? Because of the stoichiometric relationship in between these two guys. We are going to have a 2-to-1 relation. So it can react with 0.888 periodic moles of oxygen. That means that since we're going to have less oxygen available than the ones that can react with water, then the limiting reagent will be oxygen. Since 0.35 mole of O2 reacts with 0.70 mole of water. Now, how many grams of hydrogen peroxide will be produced during the chemical reaction? We have identified that the limiting reagent is oxygen, so we're going to start with 0.35 moles of oxygen. We know that 1 mole of oxygen is going to produce 2 mole of H2O2, and we know that hydrogen peroxide is going to have a molecular weight equal to 34 grams per mole. This is going to be the one of water plus the 16 grams corresponding for each of the oxygens. So 34 grams of hydrogen peroxide correspond to 1 mole of hydrogen peroxide. Notice that after this operation, the units cancel out and we're going to end up with grams of H2O2, which would be equal to 23.8 grams of hydrogen peroxide. Now, how many molecules of hydrogen peroxide would be made during the chemical reaction? In this case, we know that the amount of molecules is going to be related to Avogadro's number, since it is going to be equal to the amount of mole of H2O2 times the Avogadro's number. The amount of mole that it would be produced is going to be 0.35 times 2, the intermediate step over here, so we're going to get 0.70 mole times Avogadro's number, which tells us that we're going to have 6.022 times 10 to the 23 molecules per mole. Which corresponds to 4.2154 times 10 to the 23 molecules. And with that, it would be all. Thank you very much, and have a good one. Here in this case, since the quantities provided in the question are all up to 2 significant digits, if you want, or if it is required by your professor, you can round this up as 4.2 times 10 to the 23 molecules directly.